like I said, I'm a 6th-year PhD student in the Department of Scientific Computing, and I am also a scientific application specialist at the FSU Research Computing Center. Today's talk is going to be a short introduction to the Linux operating system, and Linux is one of those things that has it's a broad term for a lot of very slightly different things, and we'll get into that in a little while. So everybody at this point hopefully should have a Linux or Mac terminal available on your computer. If you're running on Windows, you might want to make sure and have the Linux subsystem for Windows available, or a Linux emulator like Cygwin. Those two, the Linux subsystem for Windows is fairly easy to use, and Cygwin is fairly easy to install. I'm sorry if I'm a little slow. I'm sorry if I'm a little slow at this. This is the first time I've ever done a remote seminar, so please bear with me. So, like I said, here's my introduction. Here's my introductory and basic information. So the objectives for this talk are going to be the following. We're going to cover a little bit of operating systems concepts, a little bit of Linux concepts, some file systems concepts. We're going to talk a little bit about the Linux command line, and we're going to talk about how to use that. We're going to discuss a whole bunch of useful commands in the Linux command line. We'll talk a little bit about basic systems administration, and then I'll point you to some. Then I'll give a little bit of a pitch for RCC, and I'll talk a little bit about our resources. And that's kind of important because Linux is used exclusively on RCC systems. We run a version of Linux called CentOS, and we'll discuss the various versions of Linux in a little bit. So let's go ahead. So before we get started, I think you can just raise your hand, and one of the co-hosts will allow you. Well, you can either get into the chat, or you can go and press the you can either do the chat, or you can raise your hand, and either Casey or one of the co-hosts or myself will answer the question. And I see that now. Thank you. So let's go ahead and start a little bit with operating systems concepts. So pretty much everybody has dealt with if you've dealt with a computer, you've dealt with an operating system to some degree. Pretty much everybody these days' first experience with an operating system is going to be either Windows or Mac. And that's just because Windows has sort of dominated the market for a long time in easy to use, easy to use operating systems that are meant for the everyday business and everyday professional. Mac is also very good. They tend to dominate they tend to dominate the more high-end operating system market. And so if you've worked with a computer before, you've seen an operating system. An operating system pretty much acts as a middleman between the user and the hardware. So whenever you interact with your computer through the user interface, whenever you point and click at something, whenever you run a program in the terminal, you're interacting with the operating system, not directly with the hardware. Operating systems are the main logistics centers of the computers. They handle resource and memory allocation. They handle scheduling of tasks and various interactions. They also handle efficiency and power management. So I notice this more and more. Some particularly cell phones these days if you have one of the more recent iPhones, they'll have this thing called low power mode, and whenever your battery falls below 20%, and if you press that, the little battery icon turns yellow, and that's just your phone's operating system reworking things a little bit in the background to more efficiently utilize what's left of the battery, and to also limit the amount of power that's being used. The other thing is that it sort of handles the computer's supply chain. And what I mean by supply chain is that at the very base you've got the hardware. Your hardware consists of a motherboard, a CPU, a GPU, sometimes several CPUs and several GPUs, depending on what your hardware configuration is, among many other things like CD drives, DVD drives, hard disks, solid state drives these days too. And that's all of that, and all of that's sort of the basic production level of things. One step above that is where it is basically your operating system figuring out, okay, what programs get to use what resources and when, and how do we schedule that as efficiently as possible, so that you as the user don't have to sit and wait very much for resources. As I said before, most people's first encounter with an operating system these days tends to be Windows or Mac, but it might surprise you to learn that there are a ton of different operating systems out there. Windows and Mac are probably the two dominant in the market these days. There's BSD, there's Solaris, there's ReactOS. There's a recent sort of one-off one that I've heard of recently, and then there's about 1,000 slightly different versions of Linux. Linux is one of the open source operating systems. So what that means is that you can in theory take the Linux kernel, or take the base parts of the Linux operating system, and you can write your own operating system around it. And a lot of different people have done that over the years, and a lot of people have taken what others have done and built on that, and then built on that in this long tree of succession. And we'll see. I'll show you a graph a little bit later on that sort of gives you an idea of the scale of Linux. So, like I said, Linux is an open source operating system. It's built upon an even older operating system called UNIX. Linux has been around for many, many decades now, but it was originally Unix. It's very different it's structured very differently from Windows, and it is fundamentally incompatible with Windows as a result. So if you try and run a program that was built for Linux on your Windows computer, unless you've got an emulator, it's not going to work, and vice versa, actually. Linux tends to be commonly used for scientific computing applications, which by scientific computing applications, I mean things like big weather simulations, bioinformatics, phylogenetic inference, solving partial differential equations, and various other simulations that involve that. It is also very commonly used in high performance computing settings. So whenever you see supercomputers that are basically clusters of hundreds or thousands of computers wired together, they are generally running some flavor of Linux for the most part. I'm sure there are a few that don't do that, but the majority that I've seen run Linux. So another fundamental difference between one of the main fundamental differences between Linux and Windows is that Windows is a primarily GUI operating system, meaning graphical user interface. Essentially, the best way to think about that is it's the thing you go and you point and click, and you can double click on applications, double click on folders, and you see something that's roughly a picture of what you're looking of your file or your picture or your program. This is fundamentally different, and effectively you will never see anything that's called anything like a terminal or a command prompt unless something's gone very wrong. Linux, on the other hand, is one of the operating systems where you cannot escape the command line. You cannot escape the command prompt or the terminal. And even though Linux does have some graphical user interface applications like GNOME and KDE, among others, and most of the time, if you're running Ubuntu or one of the flavors of Linux on your home computer, you'll have you'll have a GUI layer installed too. But even so, you'll have to interact with the command line. And so a very large portion of this talk is going to be talking about how to deal with the command line. So this is that image that I was talking about a while back. This is Windows is a proprietary and very linear operating system. And this slide here is just to give you a little bit of a idea of the big sort of organizational differences between Windows and Linux. Windows is proprietary, and its versions and updates tend to be very linear. So you'll have Windows 95, but you'll have nothing else except Windows 95. Then you'll have Windows 98, and there won't be any derivatives of that. You'll have Windows ME, XP, 7, 8, 10, and we won't talk about Vista. Linux, on the other hand, sort of goes like this forest, or this big phylogenetic tree almost. It starts at the very beginning, way back here. Way back before even the roots of these trees here. You see, there was Unix, and then Unix was open source, and somebody built on, and I think Linus Torvalds built on that and built Linux, and then people took that and built Debian, Fedora, Gentoo, and Arch Linux. And then people have taken those and built on that, and right at the tips of these little trees here, you can see that nowadays there's easily 1,000 different distributions of Linux you can get. Most of these distributions are to some degree compatible with one another, but not always. And so as the complexity of the different distributions grows, the compatibility between the different versions tends to break a little bit. So, like I said, Windows, Linux, so that should give you an idea that Windows, Linux, and Mac are only a few of the operating systems in the world, but those three together tend to hold most of the market share. And of that, Windows and Mac are by far the most. Linux has a small market share, and you're probably not going to see it most of the time in most business applications these days. But you will see it in scientific applications, and you will see it in research, and you will see it in supercomputing. Linux and Mac are both what's called POSIX compliant. POSIX is the portable operating system interface, and basically what that means is that there's some basic level of compatibility between these operating systems. Essentially, and in most cases, the commands that we're going to learn in this talk are going to work on both Linux and Mac, and POSIX is a very low level specification for making sure that certain things are compatible. Obviously, not everything is compatible between Linux and Mac, but some things are. So at this point, I should stop and say, are there any questions? If not, okay. If not, then I will start with file systems. So one of the primary things that an operating system is designed to do is to provide you with a file system. And so what is that? A file system is essentially it's the folders, programs, files, videos. It's everything that you generally think of as under My Documents or My Computer. And a file system takes all that stuff that you put on your computer in terms of files, programs, code, everything, and it organizes it into a hierarchical structure. Now, there are a lot of different versions of that hierarchical structure, and there's a lot of different ways of doing that. Windows and Linux do organize the folders and files in fundamentally different ways, and we'll see a little bit about that in a minute. There are also the other thing that file systems provide is a way of encoding files so that they can be stored efficiently on your hard drive. These will you'll typically see things like FAT32, ext4, exFAT, and NTFS. These are sort of the more common ones. And also, Linux and Windows fundamentally make two very different choices when it comes to both encoding and that hierarchical structure I was talking about a minute ago. So at the base, at the core of everything, all file systems, you can think of a file system as a big tree, where the root is where the root is sort of the core of the operating system. It's where all the core stuff is. It's where that Win32 file that everybody tells you never to ever delete is, because, and listen to that. You should listen to them, because if you delete that file, it's going to be bad for your Windows computer. But it's where all the really essential stuff is stored. And then from that tree, and then as you go up that tree and you go off into the branches, you start getting into things like My Computer, My Documents, the folders you put in My Documents, the subfolders within those folders, and eventually all the way down to the files. So basically this is the highest level. The root is the highest level in the directory structure. In Linux, this folder has the very descriptive name of /. In Windows, on the other hand, it's usually called something like C:/ or My Computer or something like that. Below that file, in Windows files are generally organized according to the physical device they're stored on. In Windows, you'll have this sort of theoretical root that's like My Computer, and then below that you'll have C:/, which is the main hard drive, E and F:/, which are usually additional hard drives, I:/, which is usually a network drive, and then they'll keep iterating on the letters like G, H, J, K. Those are usually external devices like external storage, external hard drives, flash drives. And usually when you're looking at this on Windows, it'll look something like this. Now, this is a fundamental difference between Windows and Linux, because on Windows, all of the file structure is usually organized to reflect the physical device, where things are located on the physical devices. On Linux, it's quite a bit more abstract. So the / folder, the root directory, is what's called the primary mount. That essentially means that this is the primary drive. This is the primary computer, and everything else is subordinate to that. Under /mnt-srv, under /mnt, /mnt is short for mount. Usually underneath that primary mount, there are other directories that will indicate other hard disks, other network drives, other flash drives, and they usually look something like this: either mnt/srv /drive or /media/usb. Now the difference here is that there's nothing there. You'll never see anything called /c or /main hard drive, because that top root directory is assumed to be the primary hard drive. And so this is one case in which translating between Windows and Linux can be a little challenging. So all files and folders on your computer can be located using a path to that folder. Now paths are generally folder names divided by either slashes in Linux or backslashes in Windows. So for example, this presentation might be in a directory called /home /alex /documents /workshops /presentation.odp. On Windows, it might be C://documents /workshops /presentation.pptx. In this case, the first slash in the top blue one here represents the root directory. Home is the name of the folder within root where all of this other stuff is. And then within home, there's a folder called Alex. Within Alex, there's a folder called documents. Within documents, there's a folder called workshop. And finally, if you go all the way down this directory structure, you'll find a file called presentation.odp. And the same sort of file structure applies on Windows, but it's organized a little bit differently. Okay, any questions? I'm going to try and make sure that there's a division that there's a break for questions between every step here. Oops. Okay, so somebody asks, what if a system has more than one hard drive? Hypothetical question. If the primary is called root, usually what you'll see is either something under /mnt. Usually under /mnt there will be mounts for other hard drives. They'll either have randomly chosen names, or you could name them. But Linux generally assumes that one of your hard drives is going to be the primary mount. So you can have multiple hard drives in Linux. It's just organized slightly differently. Does that help? Okay. Any other questions? If not, we will go ahead. Okay, so the next stop on our little journey for Linux is the Linux command line. So oftentimes you'll hear the command line referred to as the shell. Shell and command line are, in common parlance, usually interchangeable, but shell is generally the more correct term. So what is a shell? A shell is in Linux is the fundamental point of contact between you and the hardware. It's the fundamental point. It's the fundamental place where you ask the operating system, where you can request things of the operating system, and where you can enter commands, and you can work with the files on your computer. It is a primarily command line interface, so there is no graphical user interface for the command line. It is, and like I said, it is the primary point of contact between you and your computer. Effectively, the way most computers are, they're essentially organized in a little bit in this sort of hierarchy. You are the user, and what you will interact with is something called the shell. So when you enter a command, or when you open a file, to some extent you are interacting with the shell. And what the shell will do is it will go to the kernel, which is the core of the operating system, and it says, okay, go find me this command and run it. The kernel will then run that command, and it will interact, and that command will interact with the hardware to get the results you were looking for, and then it will go back up this tree to report the results to you. So there are, if you see in here, there's a whole bunch of different shells. There's C shell, there's K shell, there's Bourne shell. There's also something called the Born Again shell, Bash, which actually is one of the more commonly used shells, particularly with high performance computing systems. C shell I see a lot of too. So, like I said, the command line is the main point of interaction between the user and the operating system and the hardware. And because both Mac and Linux are POSIX compliant operating systems, their terminals are very similar, and most commands that you would run on Linux will also work on Mac. In fact, all the ones that we're gonna go over today should work on both. So the command line is used to issue simple commands to the operating system to perform tasks. Essentially, something along the lines of, "Hey, I'm looking for this file. Can you go find it for me?" Or what's the name of the computer that I'm currently running on? You can also say, what's my current IP address? Or there's also commands for like, how is my shell configured? Or for how is my shell configured, there's commands for how is my network configured? Am I connected to the internet? You can actually look at all those things through the command line. You can also monitor how your CPU is running, and you can monitor how programs and processes are running on your CPU, and a whole bunch of other things. One other thing you can do with the shell is interact with remote systems. So this is sort of like the command line version of remote desktop connections, which I imagine we're using a lot more of these days. There's a bunch of different ways of doing this, but the primary way, and the one that you'll see most often, is something called secure shell. And secure shell in the command line is referred to by the command SSH. And so if you were going to say you were on your Linux terminal and you wanted to log into HPC, for example, you could go into your command line and type SSH your FSU username at hpclogin.rcc.fsu.edu. And what that command will do is, it'll send a communication request over to one of the computers called HPC login, which will say, "Hey, I'd like to log into this computer, and here's my username." What the login computer will do is it will go and check to make sure you have an RCC account, and then if you do, it'll say, "Okay." It will send back a notification saying, "Okay, please give me your password." Then you'll type in your password, and it will repeat that. It will repeat that connection, check the password, and say, "Okay, you are who you say you are," and then it will establish a communication link between your computer and the HPC login node. And for all intents and purposes, when you're working on that remote system on the terminal, it will feel like you're working on your computer. So secure shell is really useful. So now any questions on all of that? Oops. Okay. If no questions, then we will continue and we'll start to look at some useful commands. So let's play with some useful commands. Let me see if I can get out of full screen mode here. Ah. Okay, so can everybody see that? Can everybody see this command? This little terminal prompt says base Alex, and got a little flashing cursor here. If so, then what I'm going to do is I'm going to use this terminal to demonstrate a bunch of these commands. So first off, there's a command called who am I. What this will do is it will simply list your information and tell you who you are. So if I run who am I in the prompt, it will tell me that my name is Alex, or my username is Alex. What this prints out here is the user is the first part is usually the first part of this. And what this is telling me is that I'm currently logged into to my desktop here as Alex. If I wanted to figure out what the contents of my root directory were, for example, I could type ls/, and that will print out everything that's in that home directory. CD will change the current directory. So, for example, if I wanted to change directory to desktop, I could type cd desktop and then hit enter, and now my shell would report that I am now currently in the desktop folder. If I wanted to see what the name of the computer I'm on right now is, as opposed to my username, I could simply type hostname, and that would report that my computer has this big long name that I really should change someday. The command date will list the date, time, and time zone. So if I type date, you'll see that it's currently Tuesday, the 8th of September 2020 at 3:40 p.m. Eastern Standard Time. Consequently, there's also a really interesting utility in Linux called cal, C-A-L, which will print out a neat little ASCII calendar view for you. So you can see that the cursor that this cursor is highlighted, Tuesday, the 8th of September, 2020. So this is kind of a neat little toy view or a neat little toy calendar in Linux. There's also a command called free, and what free will do is free is a bit more important because that'll tell you the amount of free memory in each partition. So one of the other things about hard disks is that the operating system can chop them up into a whole bunch of pieces called partitions, and this particularly comes up a lot if you want to run multiple operating systems. You can run Linux in one partition, and you can run Windows in the other partition. And what that partitioning does, it effectively builds a giant wall between your Linux, it cuts your hard disk in half and builds a wall in between those two pieces. And effectively, your first piece, and to your operating system, it will look like you have two hard disks. So, and because of that, it makes it so that you can effectively run Linux. You can effectively run multiple operating systems on one hard disk. So, free will tell you how much memory you currently have in your current partition. So you can see that I currently have, and consequently, what this does is it reports everything in bytes. If you were to type free-h, it will report everything in human readable format. This -h command is something we'll talk about in a little bit. It's called a command option. And what this does is it simply takes all of this stuff and translates it into something that's a bit easier to understand. So you see megabytes, gigabytes, as opposed to this, as opposed to bytes, which can be a little hard to interpret. So df will show the amount of free space in each of the mounted file systems. So what that means is if you've got a whole bunch of things plugged in along with your main Linux drive, it will show it will show the amount of memory in each of those. So if I type df, you'll see I apparently have a whole bunch of these, a whole bunch of this stuff, and it will report the amount of blocks, the amount of memory available, and the amount of memory used, and as well as the percent used. And again, it'll report that in bytes. So if I want to see that in something I can read, df-h, and you can see that the dev/sda5, which I'm pretty sure is my current operating system, is running at, has got 187 gigs used, 187 gigs available. So about 50% used. So the free and the df commands are actually really useful particularly if you've got something like particularly if you've got a remote remote storage system set up. So for example, RCC has something called archival storage, and you can have a couple of, so people will put a whole bunch of stuff in their archival storage, and it can be a little, and because it's all command line, it can be a little hard to figure out how much how much space you've actually got. So one thing you can do is SSH into your archival partition, type the df command, and that will help, and that'll help you see the df or the free command, and that'll help you see how much memory you've got. htop is also a really neat command. That will help you see, that'll show you a real-time chart of your CPU and memory usage. So if you've got a whole bunch of programs running, and you want to make sure that your programs are running efficiently and using as much CPU power as you have available, then you can type this htop command, which apparently I don't have. Okay. So let me share this one. So this is me logged into RCC. So if I type htop, you can see that this particular machine I'm running on has 24 cores, and it's quite a few of them are chugging along and running a bunch of different programs currently. You can see which programs are running and how efficiently, and also where they're running. So that's actually really useful if you want to see what processes are running, and you want to see whether or not your program is really running efficiently. One place this htop command, I actually use this htop command a lot for, is to see if a program that claims to be, it's to help me see that if I've installed a program that's parallelized, and so it's designed to run on as many CPUs as you have available. One thing htop can help you do is you can run that program and then run htop to check and make sure it's actually running on as many cores as you told it to. And finally, exit will simply exit the current processor terminal. So if you're logged into HPC here, for example, and I type exit, that'll disconnect the SSH terminal here and kick me back to my computer screen here. So if I were to type exit here, it would close my terminal. So I said before that we would look at these things called options. So basically, whenever you run a command, a command in Linux has three parts. It has the command executable, which is the command executable are all of these commands we just went through: whoami, ls, cd, and so forth. And then you can add little things called options. These usually take the form of like -l, -a, and also -h. And particularly for the free and the df commands, main options is -H, and that simply will simply mean that you want to see how much memory you've got, but you want it to be in a human readable format. In this case, what this command is saying is, I want you to list I want you to list everything in the current directory I'm in. I want you to list everything in a certain directory. I want you to list all of the files, and I want you to list more, and I want you to list more information, and I want you to list all the file permission information, which is -L. And I want you to do that in the directory called home/Bob. So arguments is, so the last part of this command is the arguments. In this case, this is basically telling the ls command where to start listing files. So it says, okay, go to home/Bob, list everything in that directory, and then list all the files, including the hidden files. What this -A does is it will list everything that's even a hidden file, and then also list it in such a way that I can see how much or how large these files are, and who owns the file, and if the file is assigned to a group. So basically, you can sum that command up as basically saying, list verbosely all files in home/Bob, and all commands that you're going to, and all the Linux commands you're going to run pretty much have this basic format. So are there any questions with that? Before I go on to a bunch more commands, there's a...
Are we supposed to be seeing another, because you are showing the terminal currently?
Oh, hang on. Why am I, oh dear God. Thank you. I'm not showing this. Am I still showing that, Casey?
Yeah, it just fixed. So why don't you
go back to this?
No, go back to the next slide. Yeah. So.
Okay. Sorry about that. I'm sorry about that. I didn't realize I was trying to share multiple things, and I didn't realize that I was on the terminal. So let's see. Okay. So all of those commands that I just went through and did are on here. Who am I? Lists your information. ls, like I said, lists the contents of a directory. cd will change the directory you're currently in. Hostname will list the name of the computer you're on right now. Date will list the date, time, and time zone. Free will list the amount of free memory. df will show the free space mounted on each mounted file system. htop will show you a real-time chart of CPU and memory usage. And exit will stop will stop the current process or close the current terminal. Essentially, all commands generally have this format. You've got a command executable, this ls, which all of these commands that we just talked about are command executables. You'll have options like -L, -A, -H, which basically tell the command executable what method or exactly how you want it to go about performing its task. And then the arguments basically will basically tell the command executable either where to do to perform its function, or sometimes how. Usually a command can be broken up into effectively a imperative sentence. It's got a verb, adjectives, and a noun. So effectively commands can be stated as do X using method Y at location Z. So in the case of that ls command, it's ls, which is list -l-a, list verbosely all files, /home/Bob in this file called /home/Bob. So pretty much all the commands that you're going to run will have this sort of setup. And like I said, are there any questions before I go on to more commands? If not, then I will move on. So there are also a whole bunch of other interesting commands. The clear command, which you may have seen me use when I was sharing the terminal without saying anything. What the clear command will do is it will clear your terminal screen. So if you've run a whole bunch of commands and your terminal screen will tend to get pretty cluttered. So you can just type clear, hit enter, and it will clear the terminal screen and get rid of all the clutter. If you click the up arrow, you can actually go back to the last command issued in the terminal. So if you need to run whatever command you just ran again, instead of having to type the whole thing again, you can just type the up arrow, and you can just hit the up arrow, and it will bring you back to the last command issued. Now, one of the interesting things about the Linux terminal is that the Linux terminal will keeps a pretty detailed history of the commands you've run back, I think at least a few days. And so you can type this up key many times to go back farther in that command history. Another thing you can do is to use the tab key. So for example, if I was going to type clear, but I couldn't remember exactly what the command was, so I typed CLE, but not clear. I could hit tab, and the command line would do its best to auto-complete this for me. This can be a bit of a challenge sometimes when you have because sometimes you'll have multiple commands that are very similar. And so in that case, if you hit the tab key a couple of times, it will show you all the possible options it found. In which case you can either type more letters until it gets down to the one you wanted, or you can just type the full one that you wanted. The history command will show you a big long history of all the commands you have issued. It doesn't go back to the beginning of time, but it goes back at least several days. And I think that really depends on how many commands you run and how heavily you use that particular terminal. A shortcut for typing the up arrow and the enter key to run your command is just typing ! enter. What that'll do is it'll rerun whatever the command you just ran was. Another thing you can do is type IP-addr show, and what this will do is it will show what your IP address is, and that's pretty useful if you're doing something that, if whatever you're doing with Linux is network heavy, or if you're needing to work a lot with the internet. This can come up a lot if you're working with web servers, or if you're working with highly detailed networks. ifconfig is what this command will do is it will show you the network device configurations. So if you've got a Wi-Fi card on your computer and an Ethernet and a relatively old-fashioned Ethernet connection cable, what ifconfig will do is it'll print out both of those hardware devices, and it'll print out the driver configuration for both of those hardware devices. This is actually really important because one thing that can go wrong, and this can happen to any computer, is sometimes your Wi-Fi card will just break. And so if you notice you can't get on the you just can't get on the Wi-Fi, your computer's Wi-Fi just won't work. Sometimes if you type ifconfig, you might see that the Wi-Fi card is no longer being detected by your operating system, which will show up as that Wi-Fi card just no longer being an ifconfig, and that can give you an idea of where to go. And that can give you an idea of where to go look for the problem. The ping command is actually really useful because is another really useful command. What ping will do is it will say you can check a remote computer. Either you can type an IP address or you can type a host name like rcc.fsu.edu. And what that will do is it will go find the IP. It will actually go find that computer and send a short little check message to see, is this computer actually up and running? Is this computer actually where the internet says it should be? And that's useful particularly if you're wanting to see if a remote computer is still up or still functioning, or if your web server or remote computer is down. And then cd tilde actually will change your current directory all the way back to your home directory. Now, tilde is one of a number of shorthands Linux has for various directories. Tilde means your home directory. In Linux, this is usually stored in slash, the root folder, and in a subfolder within that called home. So /home/Alex, for example. That would be the slash for the root directory, home for all the home directories of all of the users on that machine, and then Alex, which would be my username. So instead of having to, if I was way down in a directory tree and I wanted to get back to my home directory, rather than typing out cd/home/Alex, I could just type cd tilde and it would take me back to my home directory. So that's a nice little shortcut. Are there any questions on those? Okay. So we've already seen quite a lot of Linux commands. There are a ton more. There are a ton of them. And so sometimes you might remember a command, but you're not quite sure what it is or what it does. So you can actually type a command, what is, and then the command. And what it will do is it'll tell you what that command essentially does, sort of the short form of it. So if I type what is ls, it will give me a list of all the commands that all the commands that have the name ls, and it will tell me what they do. In this case, ls just lists the directory contents. If I type man ls, it will print out a relatively long manual entry for whatever ls is. And that manual entry will be a little bit more verbose, and you can read, and it will give you a list of all the options, and it'll give you a little detail of how the actual usage works. Consequently, if you wanted to look at the manual for most Linux commands, and the Linux manual is actually available on the internet too. So if you don't want to look for it in the command line, you can actually pull it up on the internet, and it's a little easier to read that way. Info is a command that will print out very verbose, prose-like information on whatever command you're looking up. So that tends to be quite a bit more detailed. So yeah, it'll usually give you paragraphs upon paragraphs of information that'll detail what that command is, what it does, how it works, and and so on and so forth. The type command will tell you where that command is located and what it is. So essentially, like, it'll tell you where is the command ls located. Usually what that'll mean is it will say, okay, ls is a command. ls is located in /usr/bin/ so on and so forth, and it is an executable file. Which is another way of finding out where a certain file or a command is. So if you were to type which ls, it would tell you the full directory path to where that command is located. That can be pretty useful. That can actually be pretty useful if you've got a whole bunch of programs installed and you want to figure out where a program that you recently installed was actually installed to. So are there any questions with Linux commands and getting help with all of that stuff? Okay, so next up, we're going to talk a little bit about basic systems administration. So the first part of what we went over was the basic idea of Linux, the basic differences between Windows and Linux, the basic idea of how Linux organizes its file structure, how it organizes everything, and how it views the hardware. And then finally we went over a whole bunch of simple but very useful Linux commands. All of that knowledge is sort of the prerequisite to understanding systems administration. So systems administration is actually a job title. If you go looking on Indeed or any of the myriad other jobs search websites these days, and you search for systems administrator, you'll find a bunch of hits. Essentially, what a systems administrator does is they manage computers and file systems. They will manage user accounts. They'll install and remove software. They'll manage computer resources. So for example, if you've got a bunch of shared computers, the systems administrator can manage who gets to use what when. They'll allocate computer resources and time to the people that need them. They will manage the things that are currently running on the system. They will monitor the health of computer systems, and they will help configure and manage computer services. So things like web servers, things like websites, and various other things. So a systems administrator effectively is going to need to know, particularly for Linux, a systems administrator needs to know how the file system is organized, how the computer system is laid out, and they need to know how the resources need to be allocated. So for Linux, this starts out by understanding the basic Linux file system. So the Linux file system starts out, like I said, at the root directory. Within the root directory, there's a whole bunch of stuff that constitutes the basic operating system. So within the root directory, there's a directory called bin/bin, and that's usually where all the programs that are available to everyone, to all the users on that are to all the, that's where the basic programs and all the programs that are available to everyone regardless of their user account are located. Boot is the boot sector. So this is where the Linux, so that boot sector is where the Linux equivalent of the Win32 file would be on Windows. /dev is where the devices are generally installed. So this is things like dev/sda. You'll see these often like dev/sda, dev/sdb. Those usually refer to specific physical hard drives. So things like hard drive. So things like your primary hard drive. If you've got 4 hard drives installed in a RAID configuration, you'll see those pop up under /dev. The /etc file is generally where a lot of configuration files are stored. So these are generally things like user preference. These can be things like user preferences. They can be things like language and locality settings, and many other things. Also under etc are things like module files. So module files are often used to help automate the process of loading and unloading specific software. So for example, and that's useful if you're trying to manage multiple different versions of the same software. /home is where all the users' home directory is where all the users' home directories and all the user files are stored. So if you're working on a Linux computer and you've got a user login account, then when you log into that Linux system, you will be taken to a file. You will initially go to a directory underneath home. Usually it'll be /home/ whatever your username is. And because of that, you can have dozens or even hundreds of different home directories, all corresponding to different users. And then so after home directories, there is /lib. /lib usually refers to core library files. These are usually either precompiled or uncompiled programs and pieces of programs that are required for other programs to run. And since they're in the home, and since they're part of the home directory, they're usually available across the user tree. /media is that's generally where everything that's not a part of the actual box that is your computer is stored. So when you plug in a USB drive, or you put in a CD, or you plug in an external hard drive, Linux will automatically attach those underneath media. So if you plug in a USB drive called My USB, you'll usually see that pop up under /media/My USB. So this is actually one way in which this is pretty different from Windows, because in Windows you just go to the root directory and you'd go look for the I:/ that refers to your specific USB drive. But in Linux, it's underneath this sort of master file system underneath media. /mnt is where other mounted devices are stored. So things like other hard drives, other hard drives. If you've got an external hard drive that you keep powered and attached all the time, sometimes that's under mount. Remote and network hard drives are usually stored under MNT. /opt is one of the miscellaneous files. Consequently, OPT in RCC. In RCC's case is where we install a lot of the software that people will use, like the Gaussian program, material science programs, bioinformatics programs, stuff that people will use generally sometimes go in there. Proc is really that's really an internal file. An internal folder. You don't really see that very much unless you don't see that very much unless you need to go unless something went really wrong in your Linux computer and you need to go see specifically what happened to a given process. /root is essentially the root user's home directory. What I mean by root user is the root user in Linux is effectively the same thing as the administrator in a Windows account. So for example, whenever you install programs in Windows, oftentimes they'll insist that you'll get this little pop-up that says, do you want to install this as administrator? And you'll have to click yes, and then it'll go on and install that. Essentially, the root user is the same as administrator, and what a root user can do absolutely everything. We'll get into file permissions and how to determine what the users on your system can and can't do, probably on Thursday. But the root is as a result a very special user that gets their own home directory, and that's under /root. /sbin these are system binaries, so these are things that you are probably not ever going to see unless you really need it, or you really need to do some hardcore reconfiguration of your Linux system. /srv are operating system services. /tmp that's a temp directory. So a lot of times programs that create a bunch of intermediate or temporary files will dump them to the TMP directory, and then they'll get cleaned up and deleted automatically later on. /usr is another place where user-facing programs are often installed. So user-facing programs and libraries are often installed under here. VAR is also variable libraries, and this is another place where this is another place kind of like lib, where libraries, where code, programs, pieces of programs, and uncompiled code will be stored for use by either other programs stored in other directories, or for use by people in the home directories. And lost plus found is the last thing here, and this is the Linux equivalent of the trash bin in Windows. So if you delete something, in many cases, it will end up in the lost and found, so long as you didn't do it through the command line. If you deleted something in the graphical user interface, then usually it will get dumped to the lost and found file for a little while before it gets cleaned up and tossed out. If you use the rm command in the Linux command line, it will just delete it. It won't go to lost and found. It's just gone. So we'll cover the rm command a little bit later, probably on Thursday, and that's one of the more important commands that you need to be very careful with. So I think we've only got like almost 10 minutes left. So I'll stop right here for questions. Are there any questions so far? And also to everyone, thanks for bearing with me so far. Thanks for bearing with me so far with this remote workshop thing. It's the first time I've done this. Okay, so if there are no questions, I will do a quick little wrap up here. So when we come back on Thursday, we'll cover a little bit about how to navigate the Linux file system, the user environment and environment variables. We'll cover how to find things on the Linux file system, including the grep command, which is probably one of the most useful commands you will ever learn about in Linux. I use it probably 2 or 3 times a day. at least. We will learn about piping and redirection of output. We will learn more important commands and how to manage files. We'll learn about editing files, downloading files from the internet, and we'll touch on user permissions, and groups and user groups. So that will basically talk about how do you determine what your system's users can and can't do, what they can and can't look at, and how much power you want to give them. All of those things are really important. All of those things are really important for systems administrators to know, because that will help the systems administrator set up an easy to use multi-user computer system that is relatively easy to use and doesn't cause too much consternation. So that will be Thursday. How much time do I have here? Looks like about 10 minutes, I think. In that case, I will stop here, because if I keep going, I will probably lose track of time, and and then Casey will have to yell at me to stop. So, are there any final questions? All right. Well, thank you all so much, and thank you all for attending.